Hello, and welcome to the BigQuery demo. My name is Tino Tereshko, and I'm a product manager on BigQuery. So in this demo, I'm going to walk you through some of the functionality of BigQuery, how to get started essentially, how to create tables, how to upload data into BigQuery, how to write and execute queries, but also how to secure your data, how to monitor BigQuery, and how to visualize data with some of the tools that BigQuery works with. But first, I'm going to start by showing you guys some of the scale and performance possibilities of BigQuery. Uh, BigQuery is built for scale and performance. BigQuery is powered by Dremel underneath the hood, which is Google's internal technology for data processing. So what we're looking at here is the classic BigQuery UX. This is a BigQuery Petabyte project that we use to perform some demonstrations. There's nothing really special about this project other than the fact that we have this very large table in here called sales partitioned clustered. This is a table that we created to demonstrate the power of BigQuery, and it tries to represent a typical point of sale transaction table. One thing you'll find out is that when you create an order or you process an order, generally you have multiple products that contain that order. So in traditional data warehouses, you probably want to run kind of like a star schema set of tables here. One for order and one table for all the different products that the order contains. And then you probably have some kind of key propagation, and you would probably run joins on that. Alternatively, if you're running Hadoop, for example, you probably want to decide to denormalize your data so that there's one flat table and you can query that easily. BigQuery offers kind of like a middle ground, the best of both worlds. We allow you to have nested repeated structures. So for example, the sales order lines contains multiple lines that each describe what a product was, but that all contain one specific order. So if I'm going to go ahead and click preview of this table, you see what I'm talking about, right? We have one order that has, looks like 8 individual different products that are contained in that order. So you really have the best of both worlds here. If I'm going to click on this table, you see that it's got a little bit over a petabyte of data, and it's about 1 trillion rows. This table is located in the United States. It's partitioned by date, and it is clustered by customer key. This is a new feature that we're releasing at next. So let's go ahead and run a query on it. I went into query history, and I'm going to click on some of the queries that are available to all the users of this project. This is kind of a collaboration little utility that we have. And I'm going to run this particular query, and I just want to remember that I don't want cache results. I actually want to run this query live. So what you see here, this is a typical query that anyone would want to be able to process. The one thing I want to point out is that we do have we are selecting only 1 month of the 3 years of data that's available in there. So it's a little bit of cheating here, right? But we are selecting 1 month worth of partitions, which allows us to process a petabyte of data in essentially 4 seconds. But what if we don't want to prune down to individual dates or months? Why don't we see what happens when we delete that data? Which, by the way, this query processed in 4 seconds. So now we're processing the entire petabyte of data, right? We're seeking for a specific customer key transaction across all the transactions that have ever occurred in this petabyte table, and we're going to do some aggregations and look what happened to that transaction over time. So while this query is running, it's going to take a little bit of time, a little bit more than 4 seconds to process a petabyte. I'm going to start on a new BigQuery project for us. So I'm an entirely new BigQuery user. What I'm going to do is I'm going to create a new project. I'm going to call this project Tino Project 1. And for brevity of time, I'm going to tie this project to a billing account that I already have created, so which is my own test billing account. But without that, you can create your specific credit card billing flow. So I'm going to push create, and it's going to take a little bit of time for this project to be created. As this project is spinning, I'm going to talk about what exactly does it mean to create an instance of BigQuery or to start using BigQuery. Well, BigQuery is a serverless data warehouse. What it means is that BigQuery is just APIs, right? There is no hardware there to provision or define. There are no resources to provision to define. You just have the APIs. So in order for you to use BigQuery, you make sure that your APIs for BigQuery are enabled. For me, these are enabled by default, but if I decide to stop using BigQuery for some reason in this project, I can always just disable this. So that's it. The APIs are enabled, and I should be ready to go. I'm going to call out real quick something else. IAM, right? Identity and Access Management. Since I'm the creator of this project, which, by the way, we wanted to go to the project that we just created, but the same applies to this one. Since I'm the creator of this project, I'm the owner, by default, I'm going to be in the IAM of this project. But if I'd like to, I can add any other folks. I can add my teammate Chad to this project as well, and I can turn him into a data viewer of this project only. So they can only view the data sets that are available here. Or maybe they can run queries here. I can also jump out and start creating custom roles that span multiple projects, that span multiple products, multiple different functionalities, and they can be very broad or very limited in that regard. So we have the project set up called Tino Project. We saw that the API is enabled, right? BigQuery API enabled, which should be enabled by default. We know that we have the proper credentials, right? But all that stuff happens when the project goes. Now we can go to the BigQuery API, the BigQuery UX. So what we're looking at here is our new BigQuery UX. It's going beta at next. Looks like, by the way, I just noticed that if we go to our old BigQuery UX, the query that we start running processed in about 100 seconds. So we did actually query an entire petabyte, and we did it in about 100 seconds. But it looks like we only processed 43 gigabytes. So this query, even though we're executing queries against an entire petabyte, if I was paying per query, I would only be paying, I think, a couple of cents. I can do the math on that. I would be paying less than a penny to process this query. Great. So now that we're done with this, let's go back to our new BigQuery UX. So I have my own custom projects that I just created. It's an anonymous project. There's nothing special about it. What you see here is the new UX, as I mentioned, that's going beta at next. I should call out that here on the bottom left side are all the other projects that I have access to, which includes a couple of these other projects like BigQuery Public Data, BigQuery Samples. Because BigQuery has pure separation of storage and compute, and BigQuery storage is essentially database storage, we have a number of partners ranging from websites like BBC to government agencies like the Chicago Taxi Trips, to NOAA and other research facilities that like to upload their data into BigQuery storage and give access to everyone to consume that data. So, for example, we have up-to-date, real-time weather data that we get from NOAA. And so, if you have your own data sets, you can always join them against this public NOAA weather data sets to get some value out of that. Maybe you want to see your the number of sales that you get depending on the temperature, whether it's raining or not. You can do that without actually having to upload weather data into BigQuery. It's already there for you. We finance these data sets for these providers, and so if you have public data sets that you want to share with us, please do so. Well, let's go back to the demo. So we have this project that we created called Tino Project 1. And what I'm going to do is I'm actually going to create a data set project. What do I want to call that? I want to call this Market Data, and I'm going to select the United States location. Right. So these are jurisdictions essentially, right? So the United States jurisdiction means that we're going to put data somewhere in the United States. We're going to replicate it several ways. I'm actually going to say I only want to keep this data set around for 3 days. After 3 days, it's going to get deleted automatically. So as this data is getting created, let's go click on it. Well, now inside of a data set, I can start creating tables. So the first table I'm going to create is I'm going to pull from Google Cloud Storage, right? So if I have a Google Cloud Storage bucket where I keep my data, I can actually just load data straight from there. I know this is a CSV file, but we accept all kinds of formats like Parquet, ORC, Avro, JSON. And I can actually browse to that GCS file if I'd like to. But for brevity here, I'm just going to paste the URL. It is a native table. We can create a virtual external table without, so it's going to create a table against that data in GCS. But we're going to actually create that data in BigQuery storage by loading that data into BigQuery. And we're going to call this table game reviews. It's a CSV file, but we don't really care to define what the schema looks like. We're going to let BigQuery take care of that. We know that the first header row has all the names of all the columns, so we're going to go ahead and click and start creating that table. While that table is creating, we're going to create another one, but this time I'm going to upload it from my local storage, and it's also a CSV file. I'm going to call this table game sales, and I will also let BigQuery figure out what the schema is automatically. So shouldn't take too long at all. These are relatively small tables, right? We already showed you that we can query a petabyte of data, but these are just megabytes. So this is the schema that BigQuery thinks this table has. So it's properly defined strings, integers, floats, and so forth. It's a whopping 2 megabyte table, and I can look up exactly what the data is inside of that table. You can kind of figure out what's going on in there. And same with the game sales table. Great. Now we're ready to run some queries. I am going to pop the query editor open, and I'm going to copy paste one of these queries that we wrote in the past into the window. And actually, in the query, I have game ratings, but I named the table game reviews. So I'm going to just go ahead and make sure that BigQuery auto-completes that for me. So it's just a very typical query that somebody could run. Looks like it's going to look at the scores and sales of all the different games and what the genres of these games are. Looks like it processed very little amount of data in very short amount of time here, and the results are populating here. I will show you what else you can do here. I can look at what the actual query metadata was. So the job ID is this so-and-so string, which I can send to my support people to see if there's any kind of issues potentially. I can see that this query cost us 20 megabytes, and I can look into execution details to get some metadata about what exactly happened in the course of executing this query. So potentially there's some kind of hotspot here that made this query run really, really slowly. A typical analyst or a database administrator should be able to figure out what happened here just based against this query explain functionality. It actually gives a whole lot of data, right? Every single stage of the query is described in the way BigQuery and Dremel actually look at these queries. Excellent. The other thing that I can do is I can save this query, and I'm going to call this game sales and ratings, and I'm going to give it to everyone in the project. And if I click here on the top left under save queries, and under project queries, you see that this query is now available. Fantastic. Let's open that query again, and let's run this query, and looks like caching kicked in, so this query executed much quicker than before, and it was actually free because we hit the cache. What I'm going to do now is I'm going to export this query into our new Data Studio Explorer. So with just one button, Data Studio pops up, and the query gets loaded in there. And this is just a phenomenal user interface. What I can do here now is start dragging all the different variables in here under metrics, under sorts, and so on and so forth. So I can take a look and, for example, see what the total sales are for each individual game genre. So I have the dimension of genre, metric of sum of sales, and I'm sorting by sum of sales. So look like sports is probably a very popular game genre, and action is very close behind that. So I think this is really useful information. I'm going to create a pie chart of this, and there it is. And I'm going to save this and share it with my CEO, whose name is Bob Friday. and he likes these reports on Friday, so I'm going to give it to him on as a Friday report, which, by the way, actually, if he looks at this report, will be dynamically refreshed. Great, so now we've created this report. We can start creating other reports in a similar nature in Data Studio. Super powerful, super easy to use. All right. So we've executed one query. Let's take a look at another one. This query aggregates information up to the publisher level. So it's going to show us how many publishers are generating more than $1 million in revenue and how many publishers are generating less than $1 million in revenue, just basing using basic SQL. Right? There's no joins here that we should worry about. What I can actually do is I can save this view. It will become a shortcut. But let's look at the results of this data in, I could download the results, but let's pop it into Google Sheets. This is a really popular feature because it allows people to quickly visualize and pivot and kind of look at the data in very flexible ways, just using a typical spreadsheet. So here the results are in the Google Sheet, but let me show you something that's really nifty. What I can do is I can create a variable or a parameter, and I'm going to call it over, under, in millions of dollars, and I'm going to label this one as the field that I want to look at when I do these queries. So I'm going to go to Data, Data Connectors, and BigQuery. And while this thing is connecting to BigQuery, I'm going to find my project that I created called, I believe it was called Tino Project 1. Is that what it was? Okay, I think it was Tino Project 1. Yes, it was. I'm going to take this query and paste it in here. And one thing I'm going to do is I'm going to create a parameter here. I'm going to replace this 1 million threshold here with just this variable called @mm, and I'm going to call it mm. I'm going to point to our cell that we have created for a parameter and create it. I'm going to run this query here, and Google Sheets on my behalf created a separate sheet and is pulling results from BigQuery directly in real time. But now I can hand this spreadsheet to my non-technical audience, and they can actually edit this field themselves. And let's say we change it to 10 million, we do a refresh, and now we're populating, we're trying to understand how many publishers are making more than $10 million instead of $1 million. So you can do some really interesting analysis with this in place. You can, of course, do some visualizations as well, using Google Sheets' very powerful visualization functionality as well. So now this will update automatically, programmatically, by whether the data changes inside of BigQuery or whether you change this parameter. Let's see how many more make more than 100. I'm curious to know. What is that going to give us? Oh, it looks like only 16 publishers make more than $100 million. Oh, what a shame. Great. Let's go look at something else. So, for demo purposes, we created this little video game. We call it BigQuery Breakout, and clearly I'm not very good at it, but what it's doing here is it's recording the score and it's sending that score using BigQuery Streaming API straight to BigQuery table in this project that we call Big Phaser Demo. So this is kind of like the administrator project that we've created to tie our data to this table. But since I'm not necessarily the person that's developed this game, I probably wouldn't be able to access this data unless access was granted to me. So this is the table that we're talking about here, player events. This table has a streaming buffer, and looks like data gets pulled into this table in real time automatically, right? So not a huge table, but the point is that data gets loaded into this table in real time. And you can see that some of our rows that we've made here are right at the end here, right? So these are the things that I did just now. So why don't we query this table? But again, remember that I may not have access to this table because I may be just a regular analyst rather than the creator of this game. So I'm going to go back to our Tino project, which is the anonymous project that we've created. And if I didn't have access to this developer project here called BigPhaser Demo, I wouldn't have by default rights to this table or this data set. So I may not be able to run this query, but I can ask the developer in charge of that BigPhaser Demo project for access. Here's one way of doing that. So I have this query, and I'm going to save this as a view. I'm just going to call it view. I don't have too much imagination at this point. So now that we have this view called Tino Project Market Data View, by default is not going to have access to this table here. But if I go to this game events data set, what I could do is actually share this data set. So I can share this data set with myself simply by saying, I should be able to get this data set. But if I want to only show results of that particular query, I can create an authorized view. So we called it market data view, and why don't we select it? We call it market data view is the data set project. So added it. Great. So now what we'll see here is that this view that we've created called view, the view itself has access to the raw data. But I may not have access to that raw data as a project owner or a project editor. I only have access to the results of that view. So for example, I can just select that view and run a query against it. And it looks like in the last couple of days, according to the data that we have, Bob and Frank have done really well. So I think I saved my name as Frank in this project. So what I showed you here right now is a couple of things. The first one is we have a streaming API that allows you to record actions that occur in your application, in your point of sale transactional locations, in your IoT and mobile devices, and load that data directly into BigQuery for processing. The second thing that I showed you just now is the semantics of what we call an authorized view, which is giving access to data, to mutations of data, without giving access to the data itself, right? So this view, for example, here, I may not be able to run this particular query. I may not be able to access the underlying table, but I can always run this view and get the results of the view. Fantastic. So this is essentially the basics of BigQuery, but I'm going to show you some more features here on the administration side. So the first thing I want to show you is that at Google Cloud Platform, we take security very seriously, and you should be able to set up your own customer managed keys and wire that up to BigQuery so that your data in BigQuery is protected by your keys. Again, we already showed the different APIs that are available, so I'm not going to go through that. And if we go to IAM and administration, some of the things that you'll be able to see is, for example, audit logs, which is essentially an immutable paper trail of everything that's going on inside of BigQuery. This is super relevant for compliance purposes, but also to understand if there's any kind of adverse behaviors for your BigQuery usage, or actually Google Cloud Platform usage in general. Some of the other things that might be relevant is, for example, quotas, right? Which is all the different limits that you may impose on your service, or we may have on BigQuery side. And you can actually edit these quotas, for example, as a way to protect yourself from overuse or from having too much cost. One final thing I want to show you is monitoring. So I'm going to go to, I believe BigQuery Petabyte is the data set. I'm going to show you how we do monitoring of BigQuery utilization here. I'm popped into our monitoring interface, which we call Stackdriver. And by default, I'm looking at the BigQuery Petabyte data set or BigQuery Petabyte project, which is probably a little bit more interesting of a project than the typical project that I just created. There's not much action there. I'm going to go to specifically BigQuery. And there's a bunch of data that's going on here. As you see here, there's the levels of concurrency in this project. Not a whole lot, but there is some level of concurrency. Why don't we go to 1 day? Yeah, it's not a super popular project, but there's still some action there. And here you can look at the typical histogram of all the different queries that have occurred throughout the day, and just by visually understand if your query performance does really, really well. The other thing I want to show you is that I can create custom dashboards here. So dashboards that are specifically there for my monitoring. I have 3 dashboards that I've created. One of them is called the number of queries, the typical 99th percentile of query execution, which is kind of like, let's look at the outliers of query execution, and how much data I have stored in this data set. But I can easily create another chart. Let's look at, what's a good one? I don't know, let's look at table count. And let's look at how many tables we have over the course of a week. And I'm going to go ahead and save this. And now it's just another, I might have pressed cancel. I did press cancel. But it would create, there you go. It would create another table or another chart that you can use to visualize what's going on inside of your BigQuery project. Well, there you have it. This is the basics of BigQuery, and thank you for bearing with me.